Dosto, friends, welcome to this explainer. If math sometimes feels like this super frustrating puzzle with missing pieces, or if looking at massive numbers just makes you want to close the book entirely, hey, you are definitely not alone. But today, we're completely turning that around. We're embarking on this really fun, gamified journey to unlock some serious math cheat codes pulled straight from our source material. Get ready to master the world of squares and square roots by breaking down the logic step by step.
Okay, consider this our official mission map. Today, we're battling through 6 levels: the meaning of squares, identifying perfect squares, properties of perfect squares, shortcut methods for calculation, understanding square roots, and finally, the ultimate boss, the long division method. All right, let's kick things off with level 1, the real meaning of squares.
Okay, let's dive right into it. You know that little 2 exponent symbol that hovers above a number? It often looks incredibly intimidating, but honestly, the definition is surprisingly simple. The square of a number is just the product of a given number multiplied by itself. So take away the fear of the symbol and just think of it as a number cloning itself and then multiplying. That's literally all there is to it. No complex algorithms, just a number interacting with its exact duplicate. Let's do a rapid-fire example. Take the number 8. If we want the square of 8, we just take 8, clone it, and multiply. 8 times 8 gives us exactly 64.
Let's do another quick one, just to keep the momentum going. Need the square of 12? Well, 12 multiplied by its clone 12 is 144. So the biggest takeaway here is that squaring is fundamentally just self-multiplication. Moving right along to level 2, identifying perfect squares. So now that we know what a square actually is, how do we spot a true perfect square out in the wild? Well, take a look at 25. It's a true perfect square because we can express it perfectly as a natural number multiplied by itself, 5 times 5. But then look at 26. It's totally an imposter. There's absolutely no whole integer you can multiply by itself to get 26. Think about it. 5 times 5 is 25, the next whole number is 6, and 6 times 6 is 36. The number 26 gets skipped entirely. Therefore, 26 is not a perfect square.
So, what happens when we need to verify much larger numbers where we haven't memorized the math? We use the prime factorization method. Think of it like a logical puzzle. First, we break a number down into its prime factors, like 196 becoming 2 times 2 times 7 times 7. Next, we look for matches and group identical numbers into pairs. Here, we get a perfect pair of 2s and a perfect pair of 7s. The golden rule here is if every single factor has a matching pair, you've just proven it's a perfect square. But if even one single number is left hanging without a pair, it's an imposter.
Next up, level 3, properties of perfect squares.
Okay, I absolutely love this part. We're going to unlock some secret hacks to instantly identify numbers that are definitely not squares, saving you from doing all that prime factorization math. These are your ultimate cheat codes. Check out these absolute rules. If a number ends in a 2, a 3, a 7, or an 8, it is never a perfect square. Just instantly cross it off your list. Also, if a number ends in an odd number of zeros, like 1,000, which has 3 zeros, never a perfect square. And here's a really neat trick with division. If you divide a number by 3 and get a remainder of 2, not a perfect square. Divide by 4 and get a remainder of 2 or 3, also not a perfect square. Memorize these and you'll basically be a human calculator.
And this brings us to another wild property of squares, Pythagorean triplets. You probably remember Pythagoras from geometry class, right? Well, look at how we can generate a special set of 3 numbers where the square of the largest number is exactly equal to the sum of the squares of the other 2. Using any natural number m that's greater than 1, we plug it into 3 simple formulas: 2m, m squared minus 1, and m squared plus 1. Look at the example where m equals 4. The formulas give us 8, 15, and 17. That literally means 17 squared equals 8 squared plus 15 squared. It's just a fantastic built-in structural hack for math.
All right, advancing to level 4, shortcut methods for calculation. I'm going to reveal a visual magic trick for calculating the squares of large numbers without getting all tangled up in standard long multiplication. In fact, our source material literally refers to this as jadoo, magic. It's called the diagonal method. Let's say we want to square a tricky number like 39. Step 1, draw a grid based on the number of digits. Since 39 is 2 digits, we draw a 2x2 grid and split every box with a diagonal line. Step 2, write 3 and 9 on the top and 3 and 9 on the right side. Step 3, multiply the intersecting numbers into those split boxes. So 3 times 3 is 0, 9, 3 times 9 is 27, and so on.
Finally, step 4, just add the numbers up along the diagonal paths, carrying over any extra digits to the next diagonal, exactly like standard addition. It completely transforms a difficult 39 squared into a super simple game of addition, giving us our final answer of 1,521. Welcome to Level 5, Understanding Square Roots. Consider this the boss fight of our explainer. We're now going to learn how to reverse the entire squaring process. That square root symbol with a little hook on it can look like an alien language, right? But let's demystify it right now. A square root simply asks one straightforward question. What specific number, when multiplied by itself, gives me the original number hiding under this root symbol? That's it. It's just working backwards.
Let's look at a really satisfying resolution. The square root of 256. What number times itself equals 256? Well, if we do the math, it's actually just 16. Because 16 times 16 is 256. When you realize it's just a reversal, all that math anxiety kind of just disappears.
But what if you're facing a much bigger number, like 324, and you haven't memorized all your squares? We bring back the absolute perfect tool for dismantling big numbers, prime factorization. First, we break 324 down into its prime factors. We get 2 times 2 times 3 times 3 times 3 times 3. Next, group those identical factors into pairs. We get one pair of 2s and two distinct pairs of 3s. Finally, here's the crucial extraction step. Take just one number from each pair. So we extracted 2, a 3, and another 3. Multiply those extracted numbers together. 2 times 3 times 3, and we get 18. We just use structure to easily figure out that the square root of 324 is exactly 18.
And finally, we've reached level 6, the long division method.
Welcome to the final level. Here we unlock the ultimate mathematical weapon for defeating massive, complex numbers. The sheer mechanics of this are so satisfying to watch. Let's find the square root of 784 together. Step 1. We group the number into pairs starting from the right side. So we have 84, which leaves the 7 by itself. Step 2. Find the largest perfect square closest to that first group, the 7, without going over. That's 2 squared, which is 4. We put a 2 at the top, subtract 4 from 7 to get 3, and drop down our next pair, 84. This gives us a new target number of 384. Step 4 is where the magic happens. Double your initial quotient, the 2, to get 4. Now, we have to find a matching digit to place next to the 4, and we multiply that new 2-digit number by that same digit. If we choose 8, we get 48 times 8, which perfectly equals 384. A remainder of 0 means we're done. Look at the top, and our final answer is 28. Let's reinforce this ultimate weapon on a huge 4-digit number, 5329. If you follow these structured rules we just learned, even 5329 is easily defeated. Group into pairs from the right, 53 and 29. What's the closest perfect square just below 53? It's 7 squared, which is 49. Subtract 49 from 53 to get 4, and drop down the 29. Now we have our new target, 429. Next, double that initial 7 at the top to get 14. Now find the matching digit to attach to 14. If we test the digit 3, we get 143 times 3, which equals exactly 429. The remainder is 0. We look at the top, and our square root is 73. So brilliant and so structured.
All right, you've successfully leveled up through all 6 stages today and unlocked some incredibly powerful math cheat codes. But, a true learner always tests their skills against a final challenge. So I'm going to leave you with this provocative homework question drawn straight from our source material. Based on everything we've covered today, from prime factor pairing all the way to the long division method, can you find the square root of 4356? Grab a piece of paper, set up your grid, and put your new structural skills to the ultimate test. Think you can solve it? Good luck and keep unlocking that knowledge.